Hello everyone, as Craig said, Ray Mohan. So I'm currently finishing up my thesis at Massey and have also just started with Ravensdown based down in Canterbury. So today I'll just be sharing a certain aspect of my thesis which looked at utilizing life cycle assessments as a tool to develop environmental product declaration schemes which have sort of been discussed in some of the earlier sessions today. So just to begin, what are EPD schemes? So the official definition of them are voluntary programs for the development or use of environmental labels or declarations indicating the environmental aspect of a product or service. So with these EPD schemes, they often either focus on products or organizations or a combination of the two. And they also may evaluate one or multiple environmental characteristics. So in New Zealand, we've got the Carbon Zero, so that looks at both products and organizations, and also evaluates just the greenhouse gas emissions. On the other hand, we've got Sustainable Wine Growers New Zealand. So they certify both vineyards and wineries, and also evaluate a much wider range of environmental impacts. So what's the purpose of these schemes? Now, for the consumer, an eco-label enables them to select products which best align with their personal values, and for the producer, eco-labels allow differentiation of their product so as to increase their potential market share, as well as enhance their reputation. Now, when it comes to actually increasing or achieving a premium price, the jury is still out on that, as there is quite a bit of dispute on whether that might be achievable. So, key thing to remember is that many environmental impacts may not necessarily correlate to the greenhouse gas emissions, and therefore it is extremely important to examine these impacts in addition to greenhouse gases. So one way of doing this is by utilizing a life cycle assessment. Now, LCAs are resource-based analyses, which looks at all of the inputs required to make a product and all of the resulting environmental outputs, such as the ecotoxicity and greenhouse emissions. Now, within the LCA, you've got 4 key stages. Firstly, defining the goal and scope. So this is where we identify the product that we'd be interested in. In this case, we looked at the production of raw sheep milk, and then we determined sort of what the various inputs we are going to consider. And then secondly, inventory analysis. So once we've determined the system boundary, we then collect the various data. Thirdly, going into the impact assessment. And lastly, creating some recommendations for future farm decision making. So with our LCA study on our sheep dairy case study, we looked at the cradle to farm gate boundary. So traditional LCAs utilize a cradle to grave perspective. So that's everything from resource extraction right through to the actual disposal of the product. However, in this case, because we were looking at the production of raw milk, a cradle to farm gate perspective was utilized. And this was also selected because in New Zealand, we've already had studies done on goat dairy as well as cow dairy, but nothing yet on sheep dairy, which was why we were quite keen to potentially see in the future how these 3 forms of dairy may compare. So what we looked at the production of electricity, fuel, agri-chemicals, as well as fertilizer. And barley grain has been included there, so it was used as a supplementary feed. Now, with an LCA study, we also have to incorporate all of the various inputs required to grow that supplementary feed, whether it's on-farm or off-farm. So what we've got here were the key findings from the impact assessment. So this results here have been normalized. Now, normalization is a standardized process in life cycle assessments where we compare the impacts to the impact of an average individual across a year so as to determine the relative significance. And what we found was that the terrestrial ecotoxicity actually heavily dominated the overall results. And as you can see, climate change, so that's all of your greenhouse gas emissions, which are often focused on, but with that 0.73 compared to that 5.08, it really demonstrates why you've got to look at the bigger picture when trying to determine the true environmental performance or sustainability of a farming system. So the beauty of an LCA is that once we've found or identified our key impact category we want to look in, we can then dive a little deeper and determine the various stages which are actually the key culprits in contributing to the overall impact. So in this case, we found that it was the pesticide use on farm, predominantly atrazine, as well as pesticide use in barley grain, which contributed the most. So within having identified the terrestrial ecotoxicity and freshwater ecotoxicities as being these first and second highest, the LCA system allows us to actually do sensitivity analyses to see how we might tweak the system to develop future mitigation scenarios. So one of the analyses we did was look at alternative pesticides. So for this one, we used simazine because it's suitable to be used in addition to paraquat, as well as on lucerne. And we found that there was 28% decrease in terrestrial ecotoxicity and a 22% decrease in freshwater ecotoxicity. Second one that we looked at was maize grain. Now, maize grain was selected as an alternative to barley grain just because of the similar metabolizable energy, and that was not as much of a decrease, however 7% in terrestrial ecotoxicity and 10% in the freshwater ecotoxicity. So this brings us to the second part of my thesis, which was the development of a KPI frameworks to use as a prototype. And firstly, we determined means-based KPIs based on the LCA results, and we used a framework from Lebuck et al. 2012, as seen there, where we had 4 KPIs for each of the following categories, with land management, nutrient use, pesticide use, energy and climate, and lastly, water quality. Now, just keeping in mind the time constraint, we'll only just be looking at 1 KPI for each of the following categories. So step 2 anyway, that was evaluation of current environmental certification schemes. Now the Origin Green Scheme from the Board Buyer of Ireland, that's been discussed previously. So this scheme is considered to be quite successful because while it was sort of optional, there's about 95% of all Irish dairy farms that have come on board and are technically certified. Then we also looked at Leaf Mark, which is another scheme from the UK, Unilever, which is international, and lastly, Sustainably Grown Certified, which is a scheme that started off in the US. So just these are the key fundamental KPIs. With the LCA result, we found that it was the terrestrial and freshwater ecotoxicities, which were the big culprits, and this highlighted the importance of the appropriate management of both land and soil resources, as well as just overall sustainable nutrient use. So with land management, it was the preparation of a farm-scale soil map. This is to identify areas prone to compaction, erosion, runoff, and leaching. With the nutrient use, we found that it was completing a nutrient budget, as well as conducting soil fertility and herbage or crop nutrient testing. And this was just recommended to avoid nutrient overloading, which was identified as a key area to look at. So keeping in mind that most of these KPIs are often covered in farm environmental plans, which are becoming compulsory in several regional councils, as well as down in Canterbury. So just continuing on the KPIs, with pesticide use, that was a biggie, and KPI design for that was conducting a drift risk assessment, as well as implementing some mitigations to minimize the potential drift. Energy and climate, so this was the recalculation of carbon footprint with any major livestock changes, and with some of the other sensitivity analysis which we ran, we found that the stocking rate, as well as the type of livestock in terms of whether they were lambs or rams, they greatly impacted the overall carbon footprint of our case study. And lastly, water. So this is quite standard. So this was the identification of wastewater sources as well as contamination points, as well as ensuring that all sorts of agricultural and related wastewater streams are treated appropriately prior to discharge. So to conclude, just to reiterate that the study was to demonstrate the potential use of LCA in the development of environmental certification systems for New Zealand agriculture and are not intended to be representative of the entire New Zealand sheep dairy sector. So special thanks to Jay House from the Fertiliser and Lime Research Centre, as well as Bob Longhurst from Ag Research. If you've got any further questions, please check out NZLCM, so that's New Zealand Life Cycle Management Centre, or Sheep Milk NZ in care of Craig Pritchard. Thanks for your time.